Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed about the counting semaphore. I hope you have watched that video. If you did not watch that video, I request you to go back and watch that video and come back to this video. In this video, I want to discuss about binary semaphore in detail. So I request everyone to watch the complete video for better understanding. First, let me give an overview about the counting semaphore. Then I will discuss about the binary semaphore, up operation and down operation, and how the mutual exclusion can be achieved. All these things I will discuss. Now, in the counting semaphore, we will have some value. Now, if the positive value represents that these many processes can enter into the critical session. Let's take that counting semaphore value is equal to 3. Meaning is that 3 more processes can enter into the critical session. Now let's take that process P1 wants to enter into the critical session. Okay, let's take that we have a critical session. Now process P1 wants to enter into the critical session. Now what it will do? Before it enters into the critical session, it will perform the down operation. Now down operation will reduce the counting semaphore value by 1. Okay, and this value is greater than 0, so it will enter into the critical session. Now one process is there in the critical session. Now counting semaphore value is equal to 2, meaning is that 2 more processes can enter into the critical session. Now let's take the process P2 also want to enter into the critical session. Now what it will do? Again process P2 will perform the down operation. In entry session we will perform the down operation and we will have the critical session. At the exit session we will perform the up operation. Now process P2 also reduce the counting semaphore value by 1. Okay, and this value is greater than or equal to 0, so process P2 also enter into the critical session. Now process P3 wants to enter into the critical session. Again it will reduce the counting semaphore value by 1 by performing the down operation. Now the counting semaphore value is equal to 0, so even process P3 enter into the critical session. Now if you look at the counting semaphore value is 0, so no more process are allowed to enter into the critical session. Okay, now let's take that process P4 wants to enter into the critical session. Again it will also perform the down operation, so it will become -1. As the counting semaphore value is less than 0, the process P4 goes to the sleep state. Okay, so it will be in the waiting state. In a queue, we will maintain the process which are blocked or in the sleep state. Now similarly, let's take that process P5 wants to enter into the critical session. Again it will also perform the down operation. Now counting semaphore value will be -2, which is less than 0, so even process P5 will go to the sleep state. Now if you look at counting semaphore value is equal to -2, meaning is that 2 processes are there in the sleep state. Is it clear? Are you able to understand? If counting semaphore value is a positive number, then meaning is that those many processes can enter into the critical session. If it is a negative number, those many processes are there in the waiting state or in the sleep state. Is it clear for you? Now any process leaves the critical session, then it will check the counting semaphore value. Still it is less than 0, then what it will do? It will wake up one of the process and the waked process will enter into the critical session. This is the way the counting semaphore will be useful. Now in this video, I will discuss in detail about the binary semaphore. In binary semaphore, we will have only 2 values. Okay, either 1 or 0. Is it clear? In binary semaphore, we will have only 2 values, either 1 or 0. If binary semaphore value is equal to 1, then meaning is that critical session is vacant. If binary semaphore value is equal to 0, then critical session is occupied. So if it is 1, then meaning is that critical session is vacant. If binary semaphore value is equal to 0, then it is occupied. Is it clear? Are you able to understand? With an example, I will discuss the entire solution. Don't worry. Okay. Let's consider that. Initially, binary semaphore value will be 1. Let me represent it as BS. Is it clear? If it is equal to 0, what will happen also I will discuss. Or let me first start with if binary semaphore is equal to 0, what will happen? Okay. If binary semaphore is equal to 0 and process P1 and process P2 are there and there is a critical session. Okay. Now, process P1 wants to enter into the critical session and the binary semaphore is equal to 0. Now, we will have the down operation in the entry session and then we will have the critical session, and in the exit session we will have the up operation, because we know that any process synchronization mechanism will have the entry session, then there will be a critical session and the exit session. So at the entry session you need to perform the down operation. Now look at the what the down operation is doing. If s dot value is equal to 1, meaning is that if your binary semaphore value is equal to 1, then you will keep the binary semaphore value is equal to 0 and enter into the critical session. But however, look at here, binary semaphore value is equal to 0, meaning is that this if condition is false. If this if condition is false, it will come to the else block. What is the statement is there in the else block? Put the process PCB. PCB means process control block in the queue. Okay. So let's take that you have a queue. In that queue, you will keep the process P1 in the sleep state. Is it clear? Are you able to understand? We have several states in a process. One of the state is waiting state or blocked state. Is it clear? Now, so it is in the blocked state. So now the process came from the ready state to the running state. From running state, it went to the blocked state. Is it clear? Now, process P2 wants to enter into the critical session. Even process P2 has to perform the down operation. Now look at here, binary semaphore value is equal to 0. So this if condition is false. If this if condition is false, it will go to the else block. In else block, what is there? Put the process PCB, process control block, which consists of attributes of a process such as process ID, process state, priority. All this information will keep in a queue and the process will go to the sleep state. So now no process is there in the critical session. Now both the process are in the waiting state. Is it clear? Are you able to understand? Now this is nothing but a deadlock. No process is able to enter into the critical session and both the process are waiting so that other will wake up. Is it clear? So this is a situation called deadlock. So to avoid that situation, we have to initialize the binary semaphore value is equal to 1. If binary semaphore value is equal to 1, what will happen? We will discuss now. So initially you have to keep the binary semaphore value is equal to 1. Now let's take that process P1 wants to enter into the critical session and you know that it will perform the down operation first. Now look at here, semaphore value is equal to 1. Yes, this condition is true. If this condition is true, what the process is doing, it is keeping the semaphore value is equal to 0 and enter into the critical session. Now process P1 is entered into the critical session. Okay. Now in the time, we will check whether mutual exclusion is provided or not. Meaning is that if process P2 wants to enter into the critical session, then binary semaphore should not allow it. Let's check whether it is doing or not. Now process P2 also want to enter into the critical session. Now the process P2 wants to enter into the critical session, it will perform the down operation. Now look at here. Binary semaphore value is equal to 0. 0 is equal to 0. Sorry, 0 is equal to 1. No, false. If this condition is false, then what will happen? Else part will be executed. Put the process in the sleep state. So you will maintain one queue. In that queue, you will keep the information of the process P2. Okay, is it clear? And it will go to the sleep state. Now process P2 does not enter into the critical session, so I can say that mutual exclusion is provided. Is it clear? Now let's take that process P1 has completed execute in the critical session. Then what we will do? After critical session, you will have the exit session. In the exit session, you have to perform the up operation. This one even we'll call it as V operation, and this one we will call it as a wait operation. Sorry, P operation and also wait operation. This will be called as signal operation also. Is it clear? Now look at here. In the up operation, what it will do, if Q is empty, look at here, this is the Q. Is this Q is empty? No. So if this condition is false, if this condition is false, what it will do, select a process from the Q. Select a process from the Q. In Q, what operation we will perform? We will perform the insertion and deletion operation in an order called first in, first out. This is the principle. The process which was entered into the queue first will come out from the queue first. Is it clear? So this is the process. P2 will be selected from the queue and it will be wake up. Once the process P1 was wake up, look at here. When the process P2 has entered into the queue, what are the operations it has performed? It has performed the down semaphore operation. It has executed this condition before entering to the sleep state. What are the operations it has performed? Because this is very important step. So this operation it has performed, but it has not performed this one because this condition is false. As this condition is false, it has executed this step, and this one it has executed. After this one, what will be there? Critical session will be there. So it has executed up to this part. After this critical session will be there. So once the process wake up and schedule to the running state or dispatch to the running state, because once it is in waiting state, if the process wakes up, it will go to the ready state. Is it clear? We have several states in a process. One of the state is ready state. From a waiting state, it will go to the ready state. Once it has been scheduled, meaning is that the process P2 has been dispatched from the ready state to the running state, it will enter into the critical session, because this is only in a if condition. If it is a while loop, again it will execute the down operation, but it has already executed this operation, so it will enter into the critical session. Because lot of students will confuse this one. Sir, binary semaphore value is equal to 0. Again, if the process P2 performs the down operation, now this condition will be failed. Again, the process P2 will be in the blocked state. Am I right? Is it clear? But that is will not happen, because it is just an if condition. It will execute once before going to the sleep state. It has executed up to this one. After that, there is a critical session. So once the process P1 wakes up the process P2, it will enter into the critical session. So process P1 left the critical session. Now process P2 entered into the critical session. Now let's take that. Now process P1 wants to enter into the critical session. Now already it has executed the critical session, then exit session. Now again, if there is a critical session, it has to perform the down operation. Am I right or wrong? Because in a program, you will have the non-critical session, okay, NCS, let me write it. Then if you have a critical session, you will perform the down operation. Let me represent it as a P operation, and up operation you will perform. Again, if you have a critical session, P operation and V operation. So let's take that process P1 has performed executing this critical session. Now it wants to enter this critical session. Now in that case, again it has to perform the down operation. Now look at here. If process P1 performs the down operation, this condition will be true or false, because binary semaphore value is equal to 0. So 0 is not equal to 1. This condition is failed. So the process P1 will go to the block state. Is it clear? Are you able to understand? So in both the scenarios, mutual exclusion is provided. Are you able to understand? And whether you check it, whether progress has been achieved or not. Obviously progress will be achieved. How? When the process P1 does not want to enter into the critical session, process P2 can successfully enter. How you check it? Now let's take that binary semaphore value is equal to 1. Okay, now process P1 is executing the non-critical session. So it is not ready to enter into the critical session. Now process P2 wants to enter into the critical session. What it will do? It will perform the down operation. So in the down operation, there is an if condition, semaphore value is equal to 1. Yes, binary semaphore value is equal to 1. So this condition is true. If this condition is true, it will keep the process P2 will keep the binary semaphore value as 0 and enter into the critical session. So what is meant by progress? If one process does not want to enter into the critical session, it should allow the other process to enter into the critical session if other process wants it. Is it clear? Are you able to understand? If process P1 does not want to enter into critical session and process P2 wants to enter into critical session, now process P1 should not stop the process P2. If it stops, then progress is not achieved. If it does not stop the process P2 enter into critical session, then progress will be achieved. Is it clear? So this is the way the binary semaphore value will work. And remember one thing, in the entire discussion, the binary semaphore was never a negative number. It will be either a 1 or 0. Is it clear? If it is a 1, then I can say that critical session is vacant. If it is 0, critical session is occupied. It will never be a negative number. There is a possibility of negative number in the counting semaphore. In binary semaphore, we will never get the binary semaphore as a negative number. So I hope you have understood what is a down operation, what is an up operation, and how the mutual exclusion and progress has been achieved. Even bounded weight also will be achieved. If you want to check it, you can check it. Is it clear? Because by this time you know what is a bounded weight and you can check whether bounded weight is happening or not. And as it is a software mechanism, obviously architecture neutrality can also be achieved. So all the 4 requirements of any process synchronization mechanism can be achieved using the binary semaphore. I hope you have understood the binary semaphore. If you still have any doubts related to the binary semaphore, feel free to ask me in the comment section. I will try to discuss your questions as early as possible. Thank you for watching the complete video. Have a nice day.